Welcome back, everyone, and today we're going to have some fun. Today we're going to experiment with something that I found online, and this is a shader created by Ed, can't say his last name, which creates a maze-like pattern. It's not a perfect maze that's completely traversable, but it's maze-like. It gets you kind of really most of the way there, and it's pretty dead simple. Like the actual shader code is actually really simple. So we're going to use this version, I believe, or this one, can't remember, and I implemented it in GLSL. So I got it working on a WebGL page. Now, what we're going to do is we're going to kind of go through this and see how it works a little bit. Then I'm going to show you that I put some code in there to actually change it, so this way I can kind of make it more blocky, so I can control it at a per cell level. Because the way this one is, the way this thing creates mazes is a little different, but I need it to be blocky. The reason why I need it to be blocky is I want to convert all this code into JavaScript and WebGL and actually use this as Voxel maze data. So we're going to go through how the shader works. We're going to modify it a little bit, and we're going to port all this over to JavaScript and then use this to create basically a voxel maze. So here we are. Here's the what I have implemented so far is basically what he has, right? So the idea behind it is basically the idea of grids. So if I comment this out, is this the right grid? Wrong grid. This grid. So as you can see, everything kind of lines up to the grid. So the way that maze-like shader works is that first it creates this grid, right? Then it takes that grid and then it rotates it by 45 degrees and it scales it down. I'm not sure how much does it scale it down by. It scales it down by a certain amount, but then also rotates by 45. So you end up getting the green grid. So the red grid becomes the green grid. It transforms. And if I get rid of the red grid, so you can kind of see what that red grid becomes. So it transforms into this. Now you start, once you start seeing the transformed grid, you start to realize how this really works. But it's probably not very transparent the way it is. So if I were to rotate the texture also by slightly 45 degrees, then you might start to notice the pattern. So now if I rotate, now as you can see, now that the grid's at 45, I rotated by 45 degrees since the grid is at 45. Now it's at 0 degrees. And you can kind of see every cell in the grid draws a cross. Either goes as a forward slash or backward slash, and that's all it does. And it basically, if you think about it, for every single cell, it goes into a noise function and basically pulls out information that gives you either three states: nothing, a left slash, or right slash. That's it. So he's basically that's really the whole gist of his little algorithm. It's just this rotated grid that allows you to draw left and right. The whole reason why it's drawn 45 degrees is so everything. So right now, if the grid wasn't rotated, it would look more like this. It'd be kind of like a 45-degree angle maze. So that's why he rotates the grid by 45 degrees. So this way, oops, too far. Forgot to put that in there. So everything kind of looks right side up. So that's why the grid is at 45 degrees. So when you actually draw the diagonals, they look right side up. So this works. So like I said, I managed to implement the code so I can understand a little bit how this works. I don't completely get it all, but I can kind of understand how it goes. Enough so where I was able to tinker with it after a while to do a couple of things. So like I said, it's been like almost a month since I've touched this, so I kind of forgot how I did this. Like I just kept hammering away until I got it. But I know I created another grid. Like try to calculate another grid, which is up here. Calculate voxel grid. So I think the idea is that I make a grid that's a little bit smaller than the original red grid. I think it's probably like 2 times small, or I forget. I either make the grid twice the size. I think I make the grid twice the size. Yeah, I think I make my grid twice the size, I believe. So I make this grid pop up, which is actually smaller. So the grid I'm making is actually smaller than the grid that originally was created. So let me get rid of the green rotating grid. All right, so like I said, it's been a while. So I made a grid that's smaller, and it's perfectly lined up with everything else. Lined up where all the diagonals are for the most part. So by using my third grid, which is I can kind of manipulate the data that goes into his 45-degree angle grid, I'm able to say basically if there's any diagonal line at all that exists within a cell, I want that cell to be filled up. So anything that has any white in it, any white that's drawn into it, I want to fill up the entire cell. Which would be this function. Boom. And there you go. And so now now I took all his lines, and like I said, I made it into something that's more voxel friendly, more grid friendly. Part of it is basically kind of just by resizing things. And like I said, I don't remember. Let me do 50. Refresh. Ooh, that's too much. Like I said, I kind of forgot. So that's basically the main idea, really. Is like I just created a new grid, I lined everything up, and then I kind of just played with the numbers a little bit till a point that I can, if there's data in that grid, like if there's a diagonal line at all being drawn in there, I just want to fill up the entire grid with that entire cell with a color, as opposed to just drawing a diagonal. So it's even like a partial diagonal or whatever. That all said and done, I have all this code here, and it looks like insanely complicated. But it's not. All this code is really just to demonstrate all those grids. The actual final version is this. It is this small. This is everything I really need to actually calculate the necessarily data to push into his maze GSL. So, like I said, I'm taking my grid and then using that to fill in his maze, which then gives me the noise, which then actually does exactly what I needed to do. Like I said, I can't remember. I wish I wrote more comments for this, because I'm not exactly sure how this works anymore. It's one of those things where I just hammered away at it for 2 or 3 days, and it works. But yeah, that's it. That's all you really need. All plus his maze. This is his maze shader. I wrote comments in there because I was like I said, I'm trying to understand how it works, and just a noise function, because his maze uses you can pretty much use any noise function, but I guess I found something simple and small that functioned really well with his maze function, and that's all you really need. I know there is a way to control it. Let me, before I move on to the next thing. Refresh. So there, here's the original code, and I remember if I were to change this, I think this changes the thickness. Yeah, there you go. So that's kind of how I'm filling up the cell. I'm kind of filling in the thickness, because that's kind of like with that third option is other option in there. Like I said, I've totally forgot how this works. I've been so. Or is it this one? I forget. Let me try 20. So you can kind of play around with this. Oh, well, that just makes it larger. So you can just make, it can make it smaller. And actually, one of the best things about this thing, the reason why I like this maze-like, because I probably totally forgot to show you this. It's unlimited. It's tileable, so I can actually animate this. If I take this back to my the Voxel version that I put together, his original and my modified voxel works. It's completely tileable. So ideally, you can kind of make this kind of this unlimited maze in the end, or at least a maze-like pattern. It's limitless. So with that out of the way, so all right, let's see. So now we're going to our HTML page. We're going to another HTML page that have everything set up with voxels. And I literally took all this GLSL code and really just converted it over to JavaScript. That's all I really did. So here's the random function. I wrote it in JavaScript. I even put the GSL code up here, so I can kind of reference it as I write it. Same thing with the noise function that I found. Here it is. Here's the JavaScript and version of it. The cell, it's his maze function. Oh, actually, no, it's not. Is it? No. That's mine. The get at. Yeah, and I put the lines over here. This is the maze function by Ed. It's all written in JavaScript now, so I can run it. And the cell is the little two extra lines of code that I wrote to actually make it more voxel friendly. And I just wrote it again in JavaScript, and so it calls the maze function, which calls the noise function, which calls the random function, and that's it. And then I just have this extra function where I just pass in the voxel chunk data, and then I just kind of loop through all the voxels, the X, Y, and then just convert it into like UV coordinates, like its coordinates, and just feed it into the maze function, because the maze function functions as like you got to pass in UV values. So, like I said, that's all I ended up doing, just doing it that way. Here's the rest of the code, and then you have your voxels. And the voxel engine is the one we built many videos ago. So like it's just that voxel chunk data. You just fill it in with the information you want. And we can make this as big as we want. So right now it's 10 by 10. So it's, if I look up, it's 10 across, 10 down. And if I want to, I can make it even bigger. Refresh. Now I got a nice giant maze-like thing in voxel. So can I, yeah, there you go. So you can kind of traverse it a little bit, really. Now we need is like gravity and collision detection, and this would be great. This, you can just walk around. So yeah, this is like I said, this is kind of awesome. Now the thing is, this is maze-like, so there's going to be sections that that won't completely, like you probably can't go from this corner to this corner very easily. So there's things you can do to kind of go about it. One simple solution I was thinking is that my entire grid would be, or maze, I would just have like this wall outside. So this way you can kind of walk completely around the maze. This way you can kind of get into any part of the maze, usually, pretty much. Another solution is if you want to close up the section of the maze, try to find a point, like you cut the, I was thinking like you cut the maze into 4 quadrants, and then find an entry point at each quadrant and kind of just do kind of like a kind of like some kind of walking algorithm where you can just go through and just traverse through and try to see if you can find a path, like a pathfinding thing, okay, a pathfinding algorithm that kind of traverses through a quadrant, and see if you can get into any other quadrant. Can't you, like, let's say if I start here, if I were to cut this into 4 pieces, and this is quadrant 0, this is 1, that's 2, that's 3. If I start in this quadrant, can I find a path that takes me to quadrant 1, or quadrant 2, and it takes me to quadrant 3? If I can find a path, then I'm good. If I can't find a path into, let's say, quadrant 2 over here, I just find like where there's a dead end and just cut a hole right through. So that means there's at least one pathway into quadrant 2. And you can do the same thing with quadrant 3. And once you're into quadrant 3, you can then do a path finding maybe in quadrant 2 to see if you can get into quadrant 4. And if you find a path, you're good enough. You know, that's so if you really want to make the maze perfectly like traversable, you need to take an extra step where you kind of have to make sure you can go from point A to point B. That's if you want to close up the maze. Like I said, a simple solution is just to put a wall all the way around it. So this way the person can walk all the way around, and then they kind of have to walk into the maze. But on the outside, they can kind of walk around the outside a little bit, which makes it a simple solution. And another thing you can do for fun is that you can just use like, let's say, a noise function based on this. Like if you want to make an unlimited maze, like this can be like one chunk of the maze, and then you have another chunk of the maze, and you can, if you want, you can say every maze chunk has one big room where there's like maybe a boss monster or something, and if you beat it, you get some really cool loot. So you can like use a noise function. So this way, every time you come to this maze, it's always in the same spot, where you can say, okay, use a noise function and say, I'm at this X and Y chunk. Where's a good place to put it? And then it'll give you like maybe a specific coordinate, and then from that specific coordinate, maybe you can use another noise function to determine how big the room should be. If you wanted to make the room size a little bit more dynamic. If not, you want to make every room the same size. You say, okay, here's a coordinate. The room's going to be like 10 by 10 blocks, and from that center point, you just clear out a big, huge chunk of the maze. You just flatten it out, and now you have a nice big room. You put the monster right in the middle of it, and you got yourself a very simple maze with a monster, with loot, and things like that. Or like I said, if not, like if you like say that's if you want something random. If not, just put it right dead in the center. So you have to kind of traverse through the maze and find the center of each chunk, and that's where your boss is. Another cool idea I had with dealing with this maze, when looking at it, you get a lot of these like closed off spots, and these are kind of easy to find through the data. You just go through every single cell and find any cell that has 9 surrounding cells that are filled. So that means the center cell is empty. And if you want, just pick any cell that has an empty cell next to it. Like this cell won't work. Like if anything, it's pretty much going to be a left, right, up, down, not a diagonal cell. So you just check left, right, up, down, and find one that has an empty cell next to it. Hopefully not one of these. You might have to double check to make sure. Does the next cell is not also locked in? But like I said, it'd be kind of neat where if you find one of these rooms, these little empty spots, and you just find a nice place to put it, like let's say here, this looks like a good spot. You make that into like an invisible wall, or a wall that can be that's collapsible. So if someone walks by and they notice a wall is collapsible, and you can kind of smash it with a bomb or whatever, you walk right in and you get like some fancy loot. So like some other little ideas you can do with this maze, which I might want to do in the future. Like I said, that's what I would do. I'd just make collapsible walls, and some of these little tiny cell rooms will just be free loot. You know, some maybe not rare items, maybe common items, but something you can kind of get and then you kind of resell it. You know, or you know, whatever you want to do when you deal with the game, whatever you want to do with the game. But yeah, like I said, you can just randomly put in a room there. You can get some really good loot, and then you can have these little mini rooms to give you just common loot that's hidden. And then every nook and every corner can have a monster kind of just waiting there, and you have to defeat it. You know, things like that. At some point, I might want to see if I can fix the algorithm where I can have. I want to make the pathways a little wider, so I want the pathways to be maybe 2 by 2. And then have the walls 1 by 1. So this way there's more room to kind of have monsters and you can kind of fight in. But like I said, this is a really good start. There's a lot of other algorithms out there that actually generates a really good real maze, but those are much more complicated. This, like I said, is a very simple algorithm. And like again, it's not a perfect maze, but like I said, it's simpler. It's probably easier to generate. And with a little bit of work, you can kind of really use it for some really fun stuff. Like I said, my only complaint is I want to make the space between the walls a lot thicker. So I just need to, one day I'm gonna when I'm like serious about making an unlimited maze kind of game, I'm gonna sit there and just take it apart and see if I can somehow spread things out a little bit. You know, hopefully there's a nice simple way to take this algorithm and just change it where the walls I can have more I can make the spacing between the walls more variable. But yeah. So that's it. There's your voxel maze. Like I said, it's not that hard to put together, all thanks to Ed's algorithm. It's really awesome. It was fun to kind of play with. A little aggravating because I'm not that math-centric. It took me a while to really come to understand some of it to the point where I can kind of modify it to suit my needs. So I'm kind of proud of that I was able to do that. But yeah, he does make it into 3D, but his version is insanely more complicated. But I think he's able to control width and height. But his isn't voxel based. His is SDF. So everything's completely shader generated. Yeah, like I said, Control 0. So yeah, check him out. He has a Twitter, and he has a lot of cool stuff. So definitely go check him out. He has a lot of cool things that he demonstrates and shows off. Definitely worth it. I'll put a link to his Twitter at the end of the in the description so you can check him out. And yeah, sorry I couldn't super explain all the math. I'm sorry I kind of forgot how I got it to be more voxel friendly. Like I said, I haven't touched this in like over a month. And I'm only fine. It's like I need to make these videos soon after I'm done, so this way all the information is in my head. And I need to really sit down and sometimes really do better commenting. Like the comments that weren't there for me to explain to me again how I did it. So I'm sorry about that, but you know, here's some code, here's some samples. Hopefully something you can kind of, you can try learning yourself. Like I said, I showed you the grids and the basic idea. You can come here and he kind of explains it as well. I didn't really understand it until I started generating the grids myself. That helped me understand how this works. There you go. He rotated by 45 degrees and he scaled it by 2 squared, square root of 2. So yeah, because I remember I just don't remember how much he scaled it by square root of 2, which creates this really bare bones simple 2 by 2 matrix. It's just kind of insane that's a 45 degree rotation and a scale of 2 squared. It's like it's just 1, 1, 1 minus 1. It's just funny how that turned out. It just made it super simple for him. In the beginning, I actually thought this can't be, but yeah, I sat there and tried to generate my own matrix too based on that, and yeah, it is just 1, 1, 1 minus 1. It just, I guess, just math is crazy like that, I guess. Yeah, so I guess that's it. Please like and subscribe. It helps out. And thank you to all my Patreons. I really need to find a way to say thank you to all of you guys that donate. So I guess I'll see you guys at the next video.